Good morning, students. Today we are going to discuss about a chapter which is called as alcohols, phenols, and ethers, which we are studying. So I'm going to continue the later part of this chapter. So we are discussing about dehydration of alcohols. We have discussed about dehydration of alcohols. So let us start with dehydration of alcohols. Dehydration of alcohols. When I say dehydration means removal of water. Removal of water. So to remove water, we have used different dehydrating agents such as H2SO4, concentrated. Next one, concentrated HNO, H3PO3, which is called as phosphoric acid. And I have also given PCl5, P2O5. I have given this dehydrating agents. These are all acting as dehydrating agents. In my last class, I have given rest of the dehydrating agents. Now look here. Let me take an example. C2H5OH. C2H5OH. When it undergoes H2SO4 and heat it around 443 K. So from here OH, so it is you'll get a product CH2 double bond CH2. This also I have explained. This is primary alcohol. When we take about secondary alcohol, what is going to form? See, CH3, CH, OH, CH3, H3PO4, H3PO4. From here also an alkene will be formed. From here OH, from here remove hydrogen. So you'll get CH3, CH double bond CH2. This is primary alcohol, this is secondary alcohol. Even tertiary alcohols also will give this reaction. CH3C. This also have explained. I'm just trying to revise it, then proceed for the next concept. Here also use H3PO4 and heat it. Here also heating, here also heating. So from here OH, from here H, CH3, C, CH3, double bond CH2. About this part also I have explained. Now I'm proceeding. Here what I'm going to discuss is mechanism of dehydration. Important children, you have to go through this mechanism of dehydration. I'm going to take a new page and I'll explain about mechanism of dehydration. Please take down this, and I have also completed this part in my earlier class. I just revised it now. So we are going to write mechanism. So the first step is formation of protonated alcohol. Step 1, which is called as formation of protonated alcohol. So what we are going to do is we are going to add a proton. What is meant by proton? H plus N. We are going to add H plus to alcohol. That is called as this step, formation of protonated alcohol. Let me take ethanol. H, here H, here O, here H, ethanol. Oxygen will be having lone pairs of electrons. This will protonation. So I'm going to add an H plus ion. This step is reversible. What will happen is this oxygen is having lone pairs of electrons that will be given to this hydrogen, and it is going to form this. This is called as protonated alcohol. What I have done, I have added hydrogen to oxygen. So this is called as protonated alcohol. These have different names. We can write protonated alcohol, or else we can also name it as ethyl oxonium ion. ethyl oxonium ion. Ethyl oxonium, and actually this is preferably used protonated alcohol, right? So this is about first step. What is the first step is formation of protonated alcohol. Step 2. Step 2. This is called as formation of carbocation. This is called as formation of carbocation. Formation of carbocation. This is step 2. This is slow step. As it is slow step, it is rate determining step. It is RTS, rate determining. What will happen from here? See, I'll take same this reactant, protonated alcohol, H, then C, H, H, O, H, H. Here it is having positive charge. So this oxygen having positive charge, so it will try to pull the electrons from this carbon. When it pulls the electron from this carbon will get positive charge. Hydrogen. There is no change in this carbon atom. There is no change in this carbon atom. H, C, hydrogen, hydrogen, and a positive charge will be formed. That's H2. That's H2. So this is about the second step, which is called as what is the name of second step? It is formation of carbocation. This slow step and rate determining step. Can I proceed? Take down, write down now. So after this step 3, we have step 3, which is called as formation of ethene from carbocation. Formation of, I'm going to continue from this in the next page. Third step, step 3. Step 3, which is called as formation of ethene. Formation of ethene by elimination of proton. By elimination of proton. What is this? I will explain. Now we have a carbocation which we have obtained from removal of water. So this is what we got in earlier step. From this, what we are going to do is, see, water will be present. This water can pull out this hydrogen, and this bond will be shifted here. And this bond will be shifted. So I'll get reaction like this. Even this is also reversible reaction. This carbon is having two hydrogens. Carbon, here one hydrogen, here one hydrogen, two hydrogens. Double bond will be formed. It is having two hydrogens. Now, what is formed? Alkene, ethene. What we have studied dehydration. Dehydration. What is dehydration? Removal of water. Removal of water. From where we have removal of water? From alcohols. When alcohols, we have removed water, this results in the formation of alkenes. This is what explained. I'll try to consolidate. What is the first step? Protonation of alcohol. Protonation of alcohol. Second step is formation of carbocation. Formation of carbocation. See, I'll try to extend here. Formation of carbocation. Let me complete this. Third one. Elimination of proton. Elimination of proton. See, from this we can say formation of carbocation is RDS. From this I can tertiary alcohol can undergo dehydration easily compared to secondary alcohol compared to primary. What is the reason is we know tertiary, this is order of reactivity of dehydration order of reactivity of dehydration. Order of reactivity of dehydration, which can react first tertiary, then secondary, then primary. Why? Because it is going result in the formation of carbocation. Tertiary carbocation, tertiary carbocation is more stable than secondary carbocation, then primary carbocation, then primary carbocation. So that is the reason. That is the reason. So tertiary alcohols can give this dehydration fast compared to secondary than primary. So please write down, children. You have completed, or else you can play the pause button and you can take down the notes. Very important one, this topic which I am saying. Next one, I have already discussed about oxidation reactions. I'll try to write few reactions, then I'll proceed with the phenol. Oxidation of alcohols. And in my yesterday class, I have given about oxidizing agents. Did you remember oxidizing agent? Oxidizing agent. In this oxidizing agent, I have written two. One is strong oxidizing agent. Strong oxidizing agent. Can you give examples? H plus in presence of K2Cr2O7, acidified potassium dichromate, or H plus in presence of KMF, acidified potassium permanganate. One agent. The process here is dehydrogenation. Dehydrogenation. What is meant by dehydrogenation? Removal of hydrogen. It is called as dehydrogenation. When you take about mild oxidizing agents, such as Jones reagent, CrO3 in presence of HCl. Right. Next one. Jones reagent we have studied. Next one we have studied about Collins reagent. Do you remember Jones reagent? CrO3 in presence of H2SO4, or we can also write plus acetone, or else this we can write chromic acid H2Cr2O4, H2Cr2O4. Jones reagent. Collins reagent we have discussed. PCC, pyridinium chlorochromate. These will oxidize. Which one? Mild oxidizing agent will oxidize alcohols. If you are familiar with this topic, just keep forward. I'm going to introduce next topic. Alcohols will be converted into aldehydes and ketones. This strong oxidizing agent will convert alcohols to carboxylic acids. This also I have discussed. I have just given an intro for this part. Now let me take few examples, then you will understand about this part what I am discussing. You have to read the oxidizing agents, then only you will be able to answer these questions. Now let me take an alcohol, CH3, CH2, which it is primary alcohol. Suppose if I react with PCC means pyridinium chlorochromate, I have given its what is a combination, pyridinium chlorochromate. It will be having pyridine plus CrO3 plus HCl. What will happen? This will oxidize alcohol into aldehyde C double bond OH. Remove one hydrogen from here. One more reaction will write. Let me take a secondary alcohol, CH3, COH, CH3. Try with CrO3 in presence of H2SO4 and acetone. This will be converted to ketone. CH3, C double bond O, CH3. remove one hydrogen from here, one hydrogen from here. Now this part we have completed. Next one, we can also prepare alcohols by heating alcohols. Next one, aldehydes and ketones. Prepare aldehydes and ketones. Aldehydes or ketones by heating alcohols on red hot copper tube. On red hot copper tube, we can write Cu tube or copper. They will be heating at 573 K. At 573 Kelvin. Okay, let us see this one. Let me take R C here hydrogen O H Cu 573. Same process, dehydrogenation. What is dehydrogenation? Remove one hydrogen from here, one hydrogen, and convert this CO into C double bond. That means R C. This C I have written. This oxygen place a double bond here, double bond that I have written on top, and this hydrogen is zero. I got aldehyde. Process is same. What process are oxidation? By using this oxidizing agent, mild oxidizing agent, or use copper tube and heat it, remove two hydrogens and convert, place one double bond between carbon and oxygen in this place. Then you will get aldehyde. Suppose we'll try to do it with with secondary alcohol CH3 COH CH3 and here H. Same copper and heat it for 573. From here hydrogen and remove one hydrogen from here. Place a double bond between these two. So I'll get CH3 C double bond over CH3. I got a ketone. We have already studied primary alcohols will give aldehyde, secondary alcohols will give ketone. Same. This is primary alcohol. This is secondary alcohol. Products are same. Are you writing? Can I proceed? So let us try with this same reaction, copper and 573. Dehydrogenation, that also comes under oxidation. Let us deal with another question. Let me take tertiary alcohol. See, whether you use a mild oxidizing agent or use copper and heat, the products are same. But we have discussed tertiary alcohols will not be oxidized by primary mild oxidizing agent or strong oxidizing agent. We have discussed. We have also discussed they will be converting into alkenes. Here also same. What will happen is dehydration will occur. Cu plus 573. Instead of dehydrogenation will not occur, but dehydration will occur. What is dehydration? Removal of water. From here OH, remove one hydrogen from here, one hydrogen. So I'll get CH3, this CH3, this carbon, down one carbon, CH3. From here I have removed one hydrogen, so it will become double bond CH2. So results in the formation of alkenes. Tertiary alcohols are not oxidized into aldehydes or ketones, but converted into alkenes. Yes, are you following me? Studying? Right. So I'll continue. Next one is about reactions of phenol. With this, we have completed about reactions of alcohols. Now we'll study about reactions of phenol. reactions of phenol. In these reactions of phenol shows electrophilic substitution reactions. Electrophilic aromatic substitution reactions. Phenols will show electrophilic aromatic substitution reactions. Why, sir? We'll study. Now, phenol is there. H. Suppose if an electrophile is coming, electrophile will be having positive charge. Now, this electrophile will join either in ortho or it will join either in para. So, you'll get a compounds like this. You'll get a compounds like this. Here OH, here electrophile. Ortho. Next one is this is OH, and here electrophile will be there. Here electrophile will be there. Now these type of reactions, electrophilic substitution reactions, will be shown. Electrophilic substitution reactions will be shown by phenol. Okay, sir. Now phenol. See why electrophile is going to ortho position. This is ortho position 1 2 position 1 2 and para 1 2 3 4 1 2 3 4. Why electrophile is going to ortho position and para position? This is ortho position. Maybe because I have joined this electrophile in ortho position. Here I have joined electrophile in para position. We are going to discuss that now. Benzene with OH group. Benzene with OH group. This is electron releasing group. This is plus R effect. It shows plus M effect. OH shows positive resonance. That means it gives electrons. It gives electrons to benzene ring. To benzene ring. Okay, can I take new page? I'm going to take new page. Now let me take an example. Here OH is there. It is having two lone pairs. These lone pairs will be given. These electrons will come out. This I have explained earlier in the topic which is resonating structures. Here OH, these electrons come here, so oxygen will get double bond and a positive charge will be there and negative charge will be there. Again, these electrons will undergo delocalization, that is resonance. This also have taught, just to go through it. Again, these electrons will be coming like this. These electrons will be out. Minus charge here. Finally, this will push here. I taught you how to draw the structures. When this is coming, these electrons will be taken up. H. Now look here. If an electrophile is coming, what is electrophile? Electrophile will be having positive charge. Electrophile will be having positive charge. This electrophile will join either in this position, or in this position. This position is ortho position with respect to this OH. This position is para position with respect to this OH. Again, this is also ortho position. Here negative charge is more. Here negative charge is more. Here also negative charge is more. So that is why phenol is ortho-para directing group. Ortho-para directing group. Ortho-para directing group. Or you can say phenol is ring activating group. Ring activating group. What is ring activating group? It will make electrophile to come and join easily. Why? Because it increases electron density. It increases electron density on benzene ring. So we have understood phenol shows aromatic electrophilic substitution. Phenol shows which type of reactions? Phenol shows aromatic electrophilic substitution. Electrophilic substitution. So we are going to study about which type of electrophilic substitution we are going to study is first one is called as nitration. We'll study about nitration, then we'll study about halogenation. Halogenation. Then another two reactions are there: Kolbe reaction, Riemer-Tiemann reaction. So this is what the topic which I want to discuss for today. Go through it. Then if you have any doubts, you can ask me in my coming class. What I will do is I'll start explaining the electrophilic substitution reaction shown by phenol. Bye bye. Take care, ma.